Good evening. Today we have come to the fifth day of our online lecture series, where we will hear a discussion on robotics and automation from an expert who has been doing significant work on this topic since a very young age. He is Mr. Adhik Mewada. Before that, I just introduce Mr. Adhik. He's a founder of the Chief Executive Officer of the Smowcode, a technology startup supported and funded by the premier institutions, including BITS Pilani, IIT Mandi, STPI, and SPTBI. He has previously worked as an assistant administrator at Plus Pharma and as a software developer at the Embeddles, and gaining valuable industry experience early in his career. An entrepreneur from a young age, Mr. Adhik actually began selling electronic products at the age of 18 and later made the bold decision to turn down both the partnership offer from the embedders and the job offer from the multinational company to pursue his entrepreneurial vision. He is a highly organized software and hardware developer and has also served as a guest speaker at SVMP. So hopefully you all will benefit from this from the discussion on this very important emerging technology topic, that is the robotics and automation. We request you all to keep your microphone and camera off during the session, and of course at the end of the discussion there will be a question answer session, so you can ask the question, and if you want to ask the question then you just raise your hands. I will select one by one. Okay. And last, just I tell that the all the lectures of our lecture series are being uploaded on our YouTube channel, Online MAKAUT. So request all to subscribe this channel. Now already 5:10. So I request today's speaker to start your session. Mr. Adhik, please.
Hi, Pritimoy. Thank you so much for having me here. Hi, everyone. I am Adhik Mewada. I'm the founder of Smowcode. Thank you so much for the introduction. Let me. So our topic for today is robotics and automation. What we are going to learn today is firstly what do we mean by automation, and how multiple facets of mechanics come in picture, electronics come in picture, computers come in picture, AI comes in picture to ultimately result in something that's called as automation. Everything comes under automation, so does robotics. And we are going to begin with the very top level word, which is automation. Now, can someone on the chat list down a few automations that they might have done or they might have seen happening around them, and they are very excited to maybe also discuss about them? Let us first set the let us first see how we can realize or notice such events happening around us. The chat, I hope the chat is open for everyone, and yeah, and everyone is just as pumped as they would be anyway in the morning. So yeah, please do go ahead in the chat and tell the kind of automations that you have witnessed or you are working on already. Please do. This will be an interactive session, and we will continuously keep learning from each other. We'll be understanding how in multiple ways this automation can be, in general, automation can be done by you. Yeah, yes, everyone. So let us begin with a few basic automation ideas. Okay. Let's take an example of whether or not we will be, for example, turning on a motor when a bottle is arrived. In a factory, let us say we want to apply a sticker on a bottle. Okay, the bottles keep appearing on the conveyor belt, and we need to apply a sticker to the bottle every time a bottle comes. What do we need here? We need automation. Somehow, we need to sense that a bottle has arrived and we have to apply the label. Let us say for applying the label, we just need to turn a motor, which is usually in touch with the bottle. And when the motor turns on, it rotates, and the sticker on the motor on the rotor gets applied to the bottle. Let's say there's a magical interconnection and mechanics all made. Okay, now how do we do this? We first need so many elements, is what we think that we need. Now, broadly, which exact elements do we need is something that we will learn today. Now, let us begin with a few of the basic items in automation. First, there should be a problem which needs to be solved. Okay, you need to very well define exactly what are the activities which we want to automate, and how does a normal human being automates, creates or does that work. Okay, for example, it is about sticker labeling. For example, okay, so we take it in our hand, we peel off the sticker, and then we apply it. Okay, now what all activities are there? We take the bottle, we peel off the sticker, and we apply it. Now, how many kinds of automation are there? First, there is semi-automatic and there is fully automatic. In semi-automatic, also you need to understand exactly which part you are automating. For example, you are currently taking the bottle in your hand and you're applying the sticker yourself. Now you have just created a machine which automatically peels off the label, and you can just rotate that machine around the bottle and that label is put. That is also there. That is something that we see in many of the kirana stores. So that machine comes which can just put a ticket on any product as a label, and we can just write how much rupees that item costs. So now here this was semi-automatic. Okay, it is not fully automatic because we still have to hold that bottle, we have to hold that machine, and then we have to do something. Now, for example, let us say we have to uh, press clay into a sheet or a very small thin layer. Okay, now if clay is coming in and we have to hold it and then put it in the press and then press the button of the press. Okay, click the button of the press and then it presses the clay. Okay, now that into whatever shape that we want. Okay, now that is semi-automatic. Had we connected the input of the clay with the pressing machine automatic, as in we don't need to use any of our hands, now that is fully automatic. Okay, so in a sticker example, okay, we need to understand exactly which part we need to automate. So first we have identified we need to peel off the sticker, we have to apply the sticker, and we need to take the bottle, we need to peel off the sticker, we have to apply the sticker, we have to then put the bottle in the other direction wherever whatever next process has to happen. Obviously, we are not going to do everything. We are industry. So let me also teach you how automation came in place. Okay. First, for example, there was one person who would make the bottle, who would fill the bottle with some liquid, whatever that we are selling, and who would at the end, let's say, then wrap the sticker and then close the bottle, and then put it in a carton, and then send it. And so there's only one person doing this job. Okay, and now we are able to, let's say, produce with 40 people, we are able to produce 40 bottles in, let's say, 10 minutes. Okay, now what we will do is, now so industry learned that we need to do batch work, and that's where automation came. Okay, of first grade. Not automation, we can say, there came an improvement of first grade, that one person's job is only to apply sticker. Okay, one person's job is only to, let's say, put it in the carton. Another, so that's how an assembly line was made. Okay, an entire assembly line where the journey begins from creation of the bottle, creation of the liquid, and then the liquid being put inside the bottle, then the cap being put, then the sticker being put, and then there are different people handling different items. Now that batch work increases the speed by 2x, 3x, 5x, 10x. It can go up to any amount depending on the type of the product, depending on how well they are connected. So in automation, factories are a very good example to understand how automation works. Okay, because they need to produce any product as fast as possible. Okay, they are buying machines like anything. Now we are here to make that machine because we are here to automate. This session is about how we can automate something. Okay, so now we've learned how that basic, so from one person doing all jobs to different people doing different jobs. Now these are still people, these are men, these are women, they are real people who are working right now. Now we need to remove a few, so we need to replace a few of them with just machines, and have a few of them maintain the machines, take care of the machines. So jobs will obviously be there, but their jobs are now different. Okay, but machine is taking care of the menial job. Okay, now how do we do this? So first we need to identify whichever, so while automating, we should always know which is the easiest to automate. First, you begin there. Second, you should know which is the cheapest. How much is your budget to automate something? Okay, whatever you are wanting to automate. That is how you will come to know whether you need semi-automatic or fully automatic. Let us say we are a very big company. Let us say we are L&T. Okay, Larsen and Toubro. We are a very big company, but we are only, let us say, creating 10 steel rods, okay, in a year, and the budget to create the 10 steel rods is not more than 50,000 rupees. So will we automate this or not? We won't automate this. We will rather do it manually. Now let's say we not 10 rods, we want to do 100 rods every year. Okay, then semi-automatic might work. Okay, and let's say we don't want any hamal or someone to be taking care of the steel rods or something. So we rather have a semi-automatic machine along with, let's say, a car or something. Okay, which can hold those steel rods. Okay, depending on the size of the rods. Then comes feasibility as well. So cost, transport, feasibility as in, let's say, only one item needs to be made. Okay, one big car we need to make. Okay, now how feasible it is for us to make the body of the car by hands. Okay, and how much is the timeline for that? Let's say we have to make 10 different types of car. So at the end, we have to only make one car, right? So now we might need to have manual plus semi-automatic kind of a situation. So this is basically automation, and how in the business sense you understand automation and you decide what to automate. So we all got that part, what to automate. It can be at a very top level that you need to make a decision of what to automate, and it can be at a very low level as well, that you need to know exactly what to automate. Now, that's where automation begins. Now, there are two parts of automation usually. It is three parts actually. It can be either physical, mechanical item, there can be electronics item, and there can be this thing, software item. Okay, it can be just software, it can be just electronics, it can be just mechanical, it can be all the three of them. Okay, it can be any of it, but you need to know which one to choose where. Okay, so earlier cars used to be made with mechanical brakes. Why? Because when you apply the brakes, they apply right off. It would be instant response. Okay, they didn't used to trust electronics at that time. Why? Because we don't know whether when we apply the brake, that electronic signal will go to the necessary chip or processor. It will take care of the signal, and by how much time it will give the signal out, and whether that processor is trustworthy or not. At that time, they loved mechanical. Today's juice centers as well have pure mechanical, just a motor running the juice machine. They don't have any electronics around it, which let's say speeds up the motor automatically by detecting how much, what kind of fruit is being mixed or something. No, they use pure mechanical and motor. Motor is by default, we don't include motor in electronics. We include motor as a part of mechanical element. Okay, so so basically we need to decide which one are we automating, what is feasible where. Okay, we cannot do electronic automation where the purpose can be very well served by using mechanical elements. Okay, and we also need to see budget, and we also need to see the utility of what we are trying to automate. So at your home, let's say you have to do these many waves of hand to actually open the door. Now that is good automation. Yeah, you don't have to open the door anymore, but rather just open the door manually. That would be far better. So you need to know whether there's a problem to solve. Don't just automate anything in life. Um, Okay, now we know there are multiple divisions. So let us begin with mechanical a bit. Okay, in case of mechanical, there are multiple systems that can together come in place to create to automate a system. So let's say you can just create a conveyor belt to bring something from X position to Y position. You can just create a simple cutting device using eccentric motion on using mechanical device. So there are different kind of motions that you will see. There are different kinds of tools that you can use in mechanics by way of which you can ultimately automate a process. Okay. So, for example, if you have seen your trimmer, okay, your beard trimmer, okay, it converts the mechanical motion into eccentric motion such that the motor rotates only in a clockwise or anti-clockwise. It rotates in a circle, okay, but ultimately the razor blade moves only linear. So that kind of motion you can use to automate. Otherwise, I would have to use scissors. It's nothing but a scissor. The razor, the trimmer is nothing but a scissor. Very small scissors for very fine work. So that is another mechanical automation. Now, mechanical automation can be need based. Okay, it's a very big subject. Let's not get so much into that. As you can not so it's different for different domains, and you need to be well uh, I truly believe it is a very vast field, And I also believe that anyone who knows enough about in general how mechanics works can actually automate. Even from electronics background, one can understand how you can automate a mechanical system. Uh, and also you can seek help of the right domain people. Let's say for eccentric motion, let's say for conveyor belts, let's say for a multitude of parts of of your final automation device. Okay. Now our focus will be majorly in electronics and IoT and software, which is where majority of people have problems. Mechanical is something that people are able to figure out because it's we one can see it, and there are multiple products already made, and there are just so many motions, and there is something tangible, and people have seen many automation happening already. So let us talk about electronics now. Now, how does electronics? So let us first talk about software. Actually, how software automates many items. Okay. For example, uh, let's say we have 10 numbers and we have to uh, store them. Let us store them in Microsoft Word. Okay. We have written all the 10 numbers now. Now, every time we change any number, so we also want for each of the 10 numbers, we want their multiplication by 5. Okay. Now, we wrote it manually. So there are 10 numbers and we have written its multiplication result on the side. Okay. And we have saved the Word file. Okay. Wow. Amazing. And we have printed the file as well. Now, if I want to change the 10 numbers, okay, uh, then the result will have to be recalculated by me. Okay. So I am rather better off on Excel sheet where I can create a formula. First, I will note down the 10 numbers. Then I will multiply it by 5 or whatever is needed. And then the final result, I will just say that it should be a multiplication of 5, and that's how I'll just pull it. We all know how to use Excel here. Okay. That is how I'll just automate this, and I have now achieved the result. This is semi-automatic. Now let us say so this is how a problem begins in software. Let us go very big now. Okay. There are multiple accounts in liabilities, in assets, cash flow statements, balance sheet statements. Okay, there's financial statement. There's a profit loss statement. Okay, these all have to be made by using general entries of expenses and purchases. Okay, sorry, expenses, purchases, and invoices. Okay, there are 1,000 invoices, 1,000 expenses, 1,000 purchases, and using all of these, we need to create a balance sheet. We have to create one balance sheet, one profit loss statement, and one cash flow statement. How do we do that? Now, for that Tally was made to automate this process. In Tally, one has to still manually put all the transactions happening, but once they have been put, you can now access the entire final outcome in Tally. That is software automation for accounts. Such software automation currently exists for us via this meeting as well. You just click a button and it does everything related to video calling, audio, then there's team people management, or let's say recording management, everything it does automatically. So yeah, big problems can be solved with software automation. Then there's mechanical automation. Now let's go into something that we don't know at all about, or let's say we know a little about, which are not tangible. Okay, which is embedded systems. Okay, which is nothing but electronics used for automation. Okay, we'll go deeper into this, but first I would love to understand out of everyone here, who knows how what embedded systems is? Yeah, we'll wait for a minute. Yes. So, what is embedded systems? Embedded systems the is a way by which is a device actually which controls or monitors or does both, and it is a dedicated device for a special purpose only. As in, for example, electronics can be either embedded systems or a general purpose application. Okay, so in our case, the computer that we use, the mobile phones that we use, they are not embedded systems. They serve general purpose applications. Okay, so you can do gaming on a computer, you can do video calling on a computer, you can create documents, you can do printing works. Same things with mobile phone as well. They are general purpose. They have been created in a way that they can do anything. Okay, now what processor do they use? So using an i7 processor, okay, it costs around 5 to 7,000 rupees something, okay, depending on the time. So now this processor, can we use the same processor to control temperature in a microwave oven? The microwave oven costs around 5 6,000 rupees. How can the processor be just how can the processor be 5 7,000 rupees? Now for this there are chips, special processors made which control which help in creating such very specific applications. For example, microwave oven, what does it do? It will only control temperature. Can we install games inside it? No. Can we do video calling using it? No. It is a 500 to 1,500 rupees chip, or let's say 200 rupees chip, even 50 rupees chip put inside the microwave oven. Uh, and on top of which, all the other mechanical parts of the microwave oven come to finally create the product and sell it at 6 7,000 rupees, whatever. That is the power of embedded systems. So that chip that was thus used to create a device which is only used for a specific purpose. Okay, that part of electronics used for a specific purpose is called embedded systems. So you will see embedded systems quite a lot of places. For example, your AC, then smart fans. You will also see embedded systems in cars. So in the cars, the speedometer, and also the brakes. Now they're all embedded systems. You cannot install games in them. You cannot do VC video calling using them. You cannot do that. Yes, there's an infotainment system now. That is general purpose, but that only serves the general purpose requirements. It doesn't solve small requirements. Okay, there are so many chips used in cars that when chip shortage was there, the amount of cars being built were reduced, and their production was affected. That is the amount of embedded systems put inside a car, and a car is an automation of a multitude of things. Uh, Now we've learned what embedded systems in general means. We need to now go a little deeper into exactly how uh, and which are the total details inside embedded systems. We will also see how robotics is related to embedded systems and how in general multiple mechanical elements can be controlled using embedded systems smartly, not just by turning on a motor. So we will, yeah, just one minute. Yeah. So before we proceed with the presentation, I first wanted to tell we how processes came in place and how how important it is for us to understand uh, where the technology has been till now and why the technology is how it is right now. So I hope everyone here knows what AND gates are, OR gates are, the 7404 ICs, okay, which if you connect inside a circuit, then it performs the AND operation or operation, okay. Now, the screen that you see right now in front of you, it has million plus pixels. Okay, it has so many pixels in front of you. Now, just think these many pixels, and just for one pixel, if you need one building full of such 7404 ICs, the IC is this small. Okay, but the entire building is needed just to put one pixel on the screen. That is the amount of work that is done in a computer. And now how does how is it so big and how do we handle it? So AND gates, OR gates, addition, subtraction, multiplication. Now if we connect them together, all of them together, then what do we get? We get uh, we get a full system, right? We will be now able to display a pixel. You can display the entire screen. Okay, when we connect the sufficient amount of AND gates or gates, okay, then we'll be able to create a big system. Now, if we actually have to develop a system and it takes so many AND gates and OR gates, it's not feasible. What do we do now? We will have to now think of something that doesn't take uh, so many such embedded system devices. So many AND gates and OR gates. So what we will do is we will keep the AND gates OR gates in in parallel. Yeah, we'll keep the AND gates and OR gates, okay, in parallel, and we will reuse them. So there's only one AND gate, there's only one OR gate, there's only one, let's say, XOR gate or NOT gate. Okay, we will reuse them in a timely fashion. So this is called the arithmetic and logic unit, which is run by our processor multiple times per second. Okay, and the frequency and the number of gates at a time that it can execute, okay, is the power of the processor. Okay, so this processor will be taking a code, it will be understanding what needs to be done, whether ANDing, whether ORing, whether adding, whether subtracting needs to be done, whether information transfer needs to be done, and the processor will use the arithmetic and logic unit to perform the operation. And so a processor which has 32 bits, okay, or a 64 bits, means they have 64 such AND gates connected, addition logics connected. Okay, and it can do so much in parallel. That is what a process. That's how a processor is built. So there's code, there's processing unit, which is the processor, and in total, we thus created a system which can now perform so many operations in a second that we can see the entire screen without having to use a full building worth of AND gates and OR gates. That is how much of work that gets reduced by a processor. Now, for such a processor, which is used only for embedded systems, it's cheap as well as small, and also it handles multitude of executions in millions per second. Even the chip used for embedded systems. The chip used for embedded systems is called the microcontroller. Now, let us understand what all is included in an embedded systems. Yeah. So first is the CPU, which is the microcontroller. Okay. Second is sensors and actuators. Okay. Now let us understand what transducers mean. A transducer is a device that converts mechanical energy to electrical or electrical to mechanical, some form of energy to another form of energy. Okay, that is a transducer. Now, what is a sensor and what is an actuator? A sensor is a device that converts mechanical, or let's say any kind of energy to electrical energy. Its input is any energy, output is electrical. In case of actuator, it is opposite. Input is electrical and its output is any energy. Let me just take a 5-minute break. I'll just be right back. Hi everyone. So we were at how sensors, what are sensors and what are actuators? Now, what are the examples of sensors and what are the examples of actuators? So each form of energy, you need to understand what form of energy you are taking in. So for mechanical energy, what will be the sensor? A switch. We give mechanical input to it, right? We just click, and ultimately we what we get is an electrical signal out of it. Then comes, let us say, dynamo, where we rotate, and what we get in return is we get electrical energy. Then light energy, for example, okay, light to electrical, that is a light sensor. We call it LDR. Even solar energy, solar cell is kind of a sensor, okay, but its whole job is to convert just energy and not use the final energy as a signal. Hence, we never call it a sensor. Then comes there are multiple such sensors. So there's light, there's heat. For heat, there's a heat sensor, okay, which is called the temperature sensor. It can be either positive temperature coefficient, negative temperature coefficient. There are multiple sensors available for that. Now, what are the counterparts? Let us check the final sensor as well for, let's say, audio. So that's mic that converts audio to electrical signal, okay, which is nothing but vibrations. Now, in case of actuators, the opposite is true. So, in case of, let's say, audio, what is the actuator? It is electrical to vibrations, which is speaker. For light, it is the tube light, or let's say it is the LED. For temperature, it is the heater. Okay, there's a coil that heats up. Then, in case of mechanical, there's the motor. Okay, so we know sensor, we know actuator. Okay, now let us take an example embedded system. Okay, for example, I have a mic here, and so I am currently speaking to you. Now, what are sensors and actuators, and what are kinds of energy is being used? Okay, so first, I am currently speaking on the mic. So mic is converting my audio to electrical signals which are picked by the computer. Okay, the chip. Okay, and then they are transferred to the internet via electrical signals. Okay, somewhere in the line they might be converted to wireless signals by using radio waves, by using an antenna. Somewhere else it will be picked by a radio antenna, and then it will be somehow by electrical signals at the end conveyed to the destination computer of yours, and that destination computer will convert that electrical signal into audio signal via the speaker of your computer. Or if you are connected by Bluetooth, that same electrical signal will be converted to wireless RF signal with an antenna using Bluetooth. And there's a Bluetooth receiver on your headphones, okay, which is taking in the Bluetooth signal and then amplifying it, as in increasing its volume, and then converting, giving it to the speaker in your headphone. That amplification, did you see here? That amplification was signal conditioning. So between the sensor and the chip, okay, there can be a signal conditioning device, either to increase the volume, reduce the volume, or do some addition of some audio, or anything can be there. This goes in cameras, this goes in every kind of sensor or actuator, or let's say any kind of system. Okay, it can be very complex signal conditioning as well. For example, taking the channel, your particular colors, or let's say star plus, or let's say such channel out of one wire that is coming from the cable in TV. Okay, that is a very complex system of signal conditioning, and that signal is then provided to the TV's tube. That is a little complex of signal conditioning. So let's talk about a final device. Okay, what will it contain? It will contain the chip. Okay, it will contain sensor and actuators. Okay, and it will contain signal conditioning circuits. That is how one embedded systems device can be made. Now let us learn about IoT. What is IoT now? Can someone tell me what is IoT? Anyone? Yes. Does anyone here know what IoT does? Don't just say Internet of Things. That is just the full form. So, if you okay, so Mr. Rahul Shah says smart fans or programmable keyboards. So smart fans or programmable keyboards. None of these specify right now whether they are IoT or not. If the smart fan has Wi-Fi or some way in which it connects to the internet and talks to the internet, either by sending information or taking information from the internet, it becomes an IoT device. Programmable keyboards are not IoT device. They usually don't connect to the internet directly and they do not uh, send data to the internet or get data from the internet unless they are from China. So till then we know that it is not IoT. At least not on the label it is IoT. So we need to know whether or so IoT means what? Taking any random device and connecting it to the internet is called IoT. It is literally the meaning. Okay. Now to do something useful with it is our job. It's not the job of the word IoT. Okay. What is IoT? What does IoT include? From the internet, if we can control the device or if we can monitor the device, that is called IoT. If you go to Google and you type what is the weather on Himalayas today, it will tell you. Did you have to go there to Himalayas? No, we don't need to do that. How? There is a sensor there which is continuously monitoring the temperature and it is sending it to the internet without any person over there. It is doing its job peacefully, okay? And it is the temperatures are being sent to the internet. Google is referring to those temperatures, and that temperature is then shown to us. This is IoT monitoring. Are we controlling the temperature of Himalayas? No. This is only monitoring. Control means what? Let us say there are 50 street lights on the road. Okay. Now, how do we control each of them? Will we go to each place and press the button? No. Let us say we want to turn off the lights in this domain. Okay, there are 1,000 street lights. We want to control 200 street lights only. Will we go to the 200 street lights? No. How do we do this then? We will connect all the street lights to a microcontroller based device which connects to the internet, which is costing, let's say, 5,000 rupees. Okay. and then, or maybe even 2000 rupees, and that device will continuously send the latest update of the light, let's say whether it is working or not, by monitoring its energy, that I have given you the permission to turn on, but your energy is not being consumed. That means you're not working. So that's how we it will tell whether energy is being consumed or not, whether or not the light is working. Okay, and also we will be able to then tell the internet somewhere. Okay, so the internet, how it's made, that is also something that you need to learn here. How IoT comes in picture in automation. Now we will see an interplay of mechanical, uh, electronics, and software for the automation process. Okay, what is the mechanical system here? In case of street light, not much. Okay, but the sheer part of the final electrical bulb that we need to turn on, okay, that is very close to something physical. Okay, that we need to control with an embedded systems device. Okay, so our light is what? An actuator, which we need to control using our microcontroller, which is connected to each street light. Separate microcontrollers connected to separate each street light. Okay, and each of those are connected to our server. Now, what is a server? In internet, we need to understand that there should be someone we should be able to communicate with, some one person. So you are currently communicating not to me, you are communicating with Google, and so am I. It is Google's job to communicate whatever I am saying to you and whatever you are saying to me. That is the job of Google. So what is Google here? It is a server which is running 24/7. Okay. So I should just know Google, and you should know Google. We both go to Google. Okay. And we say we want to connect, and then that's how it connects us. Okay. There are multiple ways in which we have to do that. And there are multiple user interfaces provided by you, Google. Okay. So the entire internet runs on a system majorly. It runs on this system where there's a server and there's a client. Okay. Server is like it is continuously running 24/7. Okay. And it has to take in queries and give response for the same. Okay. Giving the response, whether it depends on use cases. Okay, whether to give a response or just send yes, okay, I received everything. Okay, that is something that the server and the application and the person who is developing the server has to decide. Now, for example, we need to send some data to the internet. How do we do that? Do we give it to everyone? No. Who will take it? Even if you want to give everyone, who all are ready to take it? No. If the traffic increases on one server, they have to increase their servers. They won't do that. The more the servers, the more the electricity, the more the hardware required. A server is a computer. Okay. A server is a computer which is receiving all the data. Now, this entire computer needs to continuously be taking inputs. It needs to continuously be taking, understanding who is asking for what. Okay. And we need to enable that computer, and we need to ensure that that computer is uh, available on the internet. Okay. So there's one computer which is called the server that we enable in the internet. Okay. That will be taking in requests from multiple places, and those places will be our internet devices. So those street lights, we will tell the street lights in the internet, connect to our server, send all the information to our server. The server knows what to do with it. What will the server do with the information? It will store the information. It will do nothing else. Now, when I go from my computer to server.com, whatever my server name is, .com, I should reach the server and I should be able to access that information either in raw form or in graphical, very nice decorated form. Okay. Or let's say there are 50 or 1,000 bulbs of streetlights created in a UI in front of me. Okay. I want something beautiful. I am Mukesh Ambani. I want, and my company needs such beautiful UIs to work with. Okay. Depends on who is wanting what. Okay. So we saw how we can automate the street light monitoring, street light control, and street light maintenance services. This is just street light. Imagine the entire factory where there are thousands of workers working day in and day out, and we don't know whether someone has worked or not. I am sitting on the top floor of the factory. I don't know what is happening on each floor of the factory, whether someone is working or not, whether some machine is being used correctly or not. We need the information, very accurate information. How do we get it? We will put these embedded system devices, which cost 5,000 rupees or something, okay, on each of these machines, okay, and we'll get this information. And I want a whole map of my factory created in front of me, where there are tick marks put on every day on each of the manufacturing facilities. That is called automation in factory, and this is called an IoT digital twin that we thus did by automating the entire process plus connecting it to the internet. So accessibility is also something that internet solves. Sometimes people want to control the entire nuclear plant from one place. What do we do then? We use IoT, right? Any doubts still here? We'll wait for let's say 5 minutes. Does anyone have any doubt till here?
Yeah, Rahul Pokas asks the question. Those sensor, actuator, the etc. devices that you talked about, how can one access them?
Hi Rahul, thank you for asking the question. Now we actually are yet to discuss how we can. Uh, okay, what is your question about? Is it about how you can purchase them, or how exactly you will write a code to control it or monitor it? So, in case your doubt is on how you can purchase it, depending on the type of the yeah, depending on the type of the sensor, you just need to figure out uh, what is the energy that it has to convert from into. What kind of use case do you have? Okay, so whether you want to measure milk or whether you want to measure the amount of petrol. Okay, let's say the milk sensor is passing electricity through the milk and then figuring out how much liquid is there, then that is not something you can put in a petrol sensor, petrol measurement sensor. If electricity passes through the petrol, we all know what can happen. So you need to know the use case. You need to know the type of sensor you need, and you need to know the comfort of placing that sensor there. Okay, a sensor which is this small, which is not well connected to a chip, okay, that I cannot put on Himalayas because it takes me 2-3 lakh rupees to go to Himalayas and put the sensor. I want a 50,000 rupees sensor, something like risk architecture. Oh, okay. Yeah, so yes, sure. Yes, sure. Let me do that as well. So, like I was, so first I'll answer Rahul's question. So, in case of risk architecture, there is, okay, let us understand a bit about how computers work and what are the kinds of processors. Okay. In case of computers, first there used to be CISC computers, complex instruction set architect computing. Okay. So this in this case in CISC, the one there used to be one instruction, okay, which would carry out multiple activities. So for example, add named assembly instruction. In case of CISC, it would take it would take the two elements from the memory, it would add them, and also it would then supply it to sorry output the final result of the addition. Okay, add a comma b. Take the a from the memory, take the b from the memory, and whatever the result is, put it inside a. Okay, that is all that is done by one instruction. Then came risk, where everything is separate. Taking something from memory, you have to use MOV, move instruction, okay, or load and store instructions. Then you can use add, which will literally just add two elements from the same registers, okay, which you need to load and store to and from before and after using the add instruction. Once the addition is done, then you need to again move the final result into the final location, memory location. Okay, this was all. This is risk, and the first one is CISC. Why do you use risk over CISC? CISC is easier, right? Why? Because in case of CISC, the entire process that we are seeing, it happens in multiple clock cycles. We want that per clock cycle, one work is done. Okay. And the hardware is in a way connected in case of CISC that at a time only one instruction is being executed. Okay. So for example, there are 5 add statements. Okay. How many, and per add statement, there are 12 clock cycles used. Okay. One clock cycle is a period, a fraction of period in case of a microcontroller or a processor, okay, in which one work can be done. Any work can be done, addition, subtraction, moving, okay, something can be done. Now, let's say there are 12 such clock cycles required just to, in case of CISC, there are 12 such clock cycles which we need to run to create one, to run one add statement, and there are 5 such add statements which we have in our code. So it will take how many? It will take 60 clock cycles, right? Now, if we had risk here, so in case of risk, these 12 clock cycles are separate instructions, okay, and they are handled in a pipeline, okay. So let's say first instruction is being handled. That time, second instruction must be so the entire pipeline is made in a way that it does fetching, then it does adding, and then it does storing in different stages. So you should learn what pipeline is, okay, and then you will understand what risk architecture, how risk architecture helps pipeline, and also risk architecture in general helps increase the usability of a single instruction in terms of how what we say, from how many places it can receive information and to how many places it can send information. That is something that you can say. So Advanced Risk Machine ARM is ARM, the ARM holding company. That ARM is actually someone who has done a very good work in risk-based architecture, and it is something that is being used since uh, tens of years in the world, more than 3 decades, I think, that ARM is being used. Sorry, the risk architecture is being used, and ARM has contributed very well. Most of the microcontrollers are using ARM. Now they are shifting to RISC-V. So about risk, it is nothing but different instructions used for performing the exact same task that we do in CISC architecture. CISC architecture would include, for example, 8051. 8051 used to have CISC architecture. You would add A, comma B. Would work. We cannot do something like that in case of ARM microcontrollers. Yeah. Thank you, Rahul. Yes, you should definitely try learning more about risk, and you should try doing a project as well using risk. Try using Smowcode for your STM32 based project. STM32 is the risk. Even ESP32 has a few risk processors. You can use Smowcode for free. It has a trial as well, and you can create your project very fast, maybe within an hour. Yeah, so Devji has a doubt. How is robotics related to automation, and give some examples in reality? I will surely do that. We are currently in the IoT domain. Let me get to the robotics part as well. So we now understand how multiple so we are currently in IoT space. Let me just go ahead and help you with robotics a bit before we get a bit more into basics of electronics and embedded systems, which is required for robotics as well. So what is robotics? Robotics means controlling motion of either static robots, which don't move from their place, okay, or robots that move, where the degrees of freedom. So there are uh, multiple things that you need to learn in robotics. Okay, degrees of freedom, which tells how many dimensions of motions are there. So there's dimension doesn't mean X, Y, and Z. Okay, dimension means whether there is so in case of let's say a robot that picks up from one place to and it drops to another place. Okay, so how many such, so let's say it is only able to rotate like this, and it is able to move like this. So it has to first, so one motion, this, yeah, so 2 degrees of freedom. This got 2 degrees of freedom. Now, this has its own benefits and demerits, torque, and so many other things come in picture. So, to reduce torque or to increase the versatility and flexibility of the robot, okay, you might include more such joints which move in themselves as well. So, you can just like this way, you can pick and you can hold, and then you can. So, more number of more degrees of freedom, okay, you can add depending on your application. So there's degrees of freedom. Then there's ROS, robotic operating system, that you should learn. So how robots have their tasks aligned in the code. That's not subject of our current session, but ROS is something you should deeply understand to be able to create applications for robotics. Third is state space equations. So let's say if your robot is requiring balancing, okay? Balancing is a very, very strong mathematical subject. It is not just about knowing when to go ahead and so let's say there's a robot which has just 2 wheels, okay, and it has to balance itself with the 2 wheels itself. It doesn't have a third wheel or a fourth wheel. It doesn't have that. 2 wheels, and we need to balance the robot. How do we do that? Now, one might say that if the robot is going ahead, take it back. If the robot is going back, take it forward. No, that's not how it works. It will just to keep doing that. How much of an effort to take? That also something you need to determine, and that is not possible by if conditions. As much you might think that it is, and you might be able to achieve some results, but if I just push it manually, the robot, then your system might fail. So here comes state space equations. State space equations are multidisciplinary input and output control equations, you can say, where given, so it creates a formula. State space equations in a way create a formula by which if you given the current position of the robot, okay, it will determine what to do next on the motor side, whether to move the motor forward and by how much time. That is something that is known and given. So to create such formulas, you need to understand state space equations. Let's say you want to create a line. What do? We use linear equations. Let's say you want to create a curve. We use quadratic equations. Now, and so many different equations are there to solve multiple problems of the world. So robots use state space equations. Actually, humans use space equations to program a formula inside the robot to handle its position. So this is another something that you should learn. Now, robots can be complicated or simple as well. You can create a very simple robot that has 4 motors, and it will go somewhere, okay, via remote control, and it doesn't need to do any balancing, and it doesn't need ROS operating system. Okay, sorry, robotic operating system, ROS. It doesn't need that, and all it will do is it will turn on a light by going somewhere. Okay, depending on the location, that is something it can do. Here you don't need ROS, you don't need you just need to understand basic embedded system. Okay. Everyone here thinks robotics means a humanoid robot. No, that's not what it is. A robot is a robot is just something usually that has motion. Okay, a robot can be statically placed in one place, or it is something that moves. Okay, to control motion, to control pick and drop. Okay, that is a robots are used. So you might want to create, let's say, a delivery robot. So in that case, you just need an embedded systems device, which literally just tracks the GPS coordinates, and it follows Google Map, and it will go through roads. It will take turns, and it will reach the destination, and the parcel will be provided, or let's say the door will be opened on the big robot, which just has four wheels. Okay, so robots have multiple definitions, and in general, the entire society is made in a way that they use the word robots in multiple disciplines, in multiple sectors. So, yeah, how is robotics related to automation? By default, anyone will like to have a robot only to automate something. There are exhibitions where just to say hello to everyone, there are robots. They literally just have a screen and they just say hello, hello. That's all that they do. So obviously that is pathetic use of a very good technology, but that is something that they do usually to show that they can do something big as well with this, not just say hi. But yeah, robots are in general used for automation only. There's a process that's taking time or taking effort, or it's not feasible to be done by a human, or now you don't find it feasible to be done by a human. Earlier, it might have been. So now you would rather just use a robot to uh, automate the work. So now let us go ahead with the next part of this session. So we learned what is IoT. We learned a few applications on IoT. We have now understood what all we can automate and how we want things, and why we should automate, and only which all parts shall we automate. That is also something that we have learned. We've learned a bit about what all deeper settings or deeper configurations or deeper knowledge that we require for core robotics. So in general, robotics has, I've told you, it has the ROS system, there's degrees of freedom, there's state space equations. Okay. Now let us learn how we can program embedded systems. This is something, so see, mechanical, everyone knows how to connect a motor, how to put the housing, that we need we need a frame, we need a tank, we need to put a hole here. We can see that. Okay, that's not something we need to learn so much, and you know how, in general, to direct someone to create something like this, or you can whether to trust whom and how big an application can be by seeing the physical size. Okay, you can do that. But in case of embedded systems, you might not understand that. But that is something we will understand now. Software is something that we all have a good idea of, that yeah, it's a website, yeah, there's an algorithm running behind it. Okay, but in case of embedded systems, it's a little tricky. It's uh, Software usually runs on Intel processors, AMD processors, NVIDIA GPUs. Okay, but in case of microcontrollers, in case of embedded systems, it runs on any microcontroller. Okay, and every microcontroller has its own way of programming. So, can someone list down the sources of the chip manufacturers and microcontroller domain? So we'll understand the complexity. Can someone list down, or let's say tell the chip manufacturers that are there in for microcontrollers?
এই যে বড়রা খাবেন একদম গরম গরম একদম গরম গরম ঠিক আছে বাড়ি যাবো নাকি? আচ্ছা, ঠিক আছে।
Dr. Chandan Jana, please mute your microphone.
বলেন গরম গরম খাবেন
Chandan Jana, please mute your microphone.
ভাই খাবেন নাকি বড় গরম 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 গরম
Yes, continue.
Yes. Does anyone know here where microcontrollers are being manufactured? Who are the manufacturers? Raspberry Pi is not a microcontroller. It's a processor. Hi everyone. So see, microcontrollers are manufactured by Espressif, by Texas Instruments, by STM32, by ST Microelectronics, by Renesas, NXP. These are a few microcontroller manufacturers who you need to know to create uh, good embedded systems applications. Now, these embedded system applications can have multiple features. So if you're creating an embedded system application for automobile, anything, two-wheeler, four-wheeler, truck, anything, you need to ensure that you're following a few compliances. In case of this, the compliances will include, for example, that your code, if there are coders in this meeting, then they would understand that if condition has an else as well. So in automobiles, any code written for any of the chips in automobile should have an else also that is being handled. You cannot just have an if. You need to handle every case. So a default case and switch case. Okay. There are a few coding regulations. Then there are a few hardware regulations as well, where the government wants the chip manufacturers to have the chip designed in a very particular way, such that the chip can also never fail. And the chip has to be very secure. It cannot be having any security failure. Else, next thing we know, China controlled all cars of India, and there are accidents happening everywhere, and half of the people died. That's also something that we cannot do. So, and Chinese chips are not allowed, or there are multiple things, okay, that automobiles have to go through. Automobiles are mission critical applications where nothing can fail. Then comes aviation in case of airplanes. So there are some rules by aviation department that if you have one motor to control the wheels, okay, whether they should come out or go up, then there should be another motor as well to control the same wheels, that part. Okay, so if one motor fails, another is there to save the plane. It's okay to have two motors there, but there shouldn't be a failure here. And both should be tested and they both should be working before the plane flies. Then the fuel should be at this much percentage. And these all regulations are there not just in mechanical elements, but also in electronics elements. So you need to understand always that uh, what one is, what someone is doing, what we have to take care of in case of which kind of application we are in. In case of medical, we cannot have 230 volts ever get in touch with the human. If that happens, then the AC will get in contact with the human, and the person who was anyway suffering and you have to solve the issue for him is dead. So we cannot do that as well. So we need to be very serious in multiple applications in terms of compliances, in terms of regulations, in terms of uh, our responsibility, okay, in how we are providing solutions. Then there are, in case of Europe, so there are CE certifications. There are multiple ROHs and so many other certifications that you keep seeing. These all apply to electronics as well. That the electronic should not give out electricity. It should not. It should, if it is taking 230 volts, it should also have an earth that it takes, and it takes it very well. And its circuit is created in a way that the earth is not just taken and kept hanging; it is actually used everywhere, and the final user doesn't ever get a shock. These all items are required in multiple physics. Now we have learned how we can create applications for multiple different use cases. We know actuators are required, sensors are required. Okay, we also tried understanding about the way I will communicate to you and what all sensors and actuators came in between. Okay, it's a matter of decision. Now, how to write a code for this? Okay, now there are so many chip manufacturers in microcontrollers. Okay, NXP is very famous for automotive. ST and NXP together are very famous for aviation. Then there is Renesas, which is also famous for automotive. Expressive and Qualcomm, Quectel, they are very much famous for wireless applications. Then comes Qualcomm for audio applications. Qualcomm doesn't sell to anyone who is not buying 10 million chips. You have to be let's say a big player, let's say Boat, or let's say Noise, or let's say even big players like Bose or Skullcandy, or any big players only can order from Qualcomm. That is something. So depending on the type of chip that you then use based on your end use case, you have to use their software with their way of coding, with their libraries, with their different instructions, and ultimately you will be able to create an embedded systems device using their platform. That is what is called difficult. Okay, and that is something of a very big gray area, not gray area, a dark area for many of the professionals. Okay, including professionals in industries working on this actively. Today, I don't know how to work with Qualcomm's chips. I know that I'll have to call them multiple times, but I know that I don't know yet how exactly it works. I know how to work with a few chips that I've already worked with, but I don't know anything about how to work with the other chips. Okay. So this difficult process of understanding each chip's different parts. Okay. What do we want to do? We want to control a motor. What do we want to do? We want to take some audio input. What do we want to do? We want to just turn on a light or let's say monitor some energy. Is this concept hard? No, but it is so tough to create the code for it because there are various chip manufacturers expert in various different domains. Okay, now for this, I let me share my story with you of what we do and what my company does. So I was in engineering. I was in second year. Actually, before that, I was in diploma last year, and I was doing my internship. I had a 1 year full internship. Okay, I am from electronics background, and I was embedded systems developer. I was creating a I was creating a microcontroller based device to do what? To display how much milk is in a tank. That device had a screen which would connect to the milk tank, okay, via a sensor, and that device would display how much milk is in the tank. So there are these big dairies who store big amounts of milk, okay, and they need a device which shows with an indication that this many 2,000 liters of milk is there, 3,000 liters of milk is there. So that we were developing. I had created that application. What was the sensor? The pressure sensor in the bottom of the um, tank, which would measure, which would come to know how much of liquid is there in the tank, and then that sensor, I have to read from that sensor and I have to display on the screen 5,000 LTR liter. That is something I have to do. Now this application is one application. Second was truck inclination application I used to work on. Okay, the truck driver should know at how much inclination he is driving. If the inclination goes beyond a certain point, he should be warned to, and he should be warned even more if he's almost on the edge of falling. Okay, that application I used to do. I used to take an accelerometer sensor, which is there in our phone as well, and that accelerometer sensor would be inside the truck. Okay, and that inclination we would receive from accelerometer based on the gravity it is detecting. Okay, and acceleration. Gravity is nothing but acceleration. Okay, so it detects the acceleration on each axis. If the z-axis has all the acceleration, that means the truck is all good. But if the x-axis or negative x-axis has the acceleration, okay, of gravity, 9 meter per second square, whatever, 9.8 meter per second square, okay, then that is wrong. So that is something I would detect and I would determine and I would tell. Firstly, I had to show the truck moving. So that is something I would show. And later I would put a condition inside it that if the inclination is higher than this, whatever xy amount, I would calculate the angle as well by that acceleration. And that angle, if it is higher, then I have to start the beeps. So that is something that device would stay inside the truck's next to the driver. Okay, that device would be kept, and that device would keep showing this is the solution. This is whatever the inclination is. Now let's come to the main part. My boss would write a logic diagram on a sheet of paper and he would leave. Okay, I had to write that code for those applications of milk tank or let's say this inclination part. I had to physically write the application, the code. Okay, 10,000 lines of code I would have to write. Yeah. So I would request Pritimoy to remove the required person. So yeah, I would have to write so much of code, 10,000 lines of code, and it would take me 3 weeks to write that code. Okay. I said, what if there were blocks of code which would create industry grade code, okay, internally. So let us say there is, um, so let us say there's a block that we use, take reading from sensor, and there's another block that we use that gives out the reading to the display. Okay, take reading, send to display. If there were these two blocks that I would connect and I would click a button and that code would go inside my microcontroller and it would start running. Okay, that would be magic, right? Or let's say there's a prompt that I would write and it would understand the uh, how to use the sensor and also how to program that sensor for this particular microcontroller, and it would work as well. Okay, which is something that AI is not able to do today. Then that would be so good. Okay, currently even using AI, when people are developing code for microcontrollers using C language, it is the user takes 90% of the time in just debugging the code created by AI. And this is for embedded systems. Why? Because AI is not expert in creating embedded systems code for those particular microcontrollers that we want to use. Okay. AI is actually not an expert of any microcontroller because AI is expert of coding Intel chips, the AMD chips, okay, Windows code, Linux code, Apple Mac OS code, okay, Android code, iOS code. They cannot go to 1,000+ microcontrollers and support so many different architectures. They cannot do that. That is where I thought, Adhik, we need to create a coding language that just accepts this logic diagram and ensures that the user just has to develop the logic and the code is done. That is something that we built. I hope everyone is with me. Now I'll show you the demo that in 2019, when I thought of something like this, after finishing my diploma, I joined my dad for 2 months in the vacation. I learned some business. Then in degree, when I came in second year engineering itself, I developed the coding language. And after that, we received capital from IIT Bombay, BITS Pilani. Then there's Contact VC, there's Software Technology Parks India. These big institutions of India funded us, and we have been used. Our software has been used to produce applications for steel cutting, monitoring, and so much more. Let me put a face to the name. Let me show you a demo of how you can very easily and quickly code using our software. Yeah, let me share the screen with you. Yes. So this is our software Smowcode for embedded systems, for automation, for robotics. Okay, for the part that we support right now, and you can select the microcontroller of your choice. We are choosing ESP32 for now, which has Wi-Fi, Bluetooth, and multiple features. Before I go ahead with this, I want you to take a look at Smowcode's website for some time, and I'll just take a break for 5-10 minutes. Have been speaking for some time, and then I'll very nicely help you with the demo of Smowcode. Via this demo, you all will learn how to code within uh, 5 minutes. Okay, is everyone there now? Shall we resume? Everyone who is there in the meeting and actively wanting to understand how we are going to write code and is excited to know what we are going to do next, just raise their hand. Raise your hands. Yeah, there's only one person. There's a raise hand option. Okay. Only two people. Come on, I need some good hands to continue now. The more the time we take to raise hands, the lesser we will have time to interact after the session, and the lesser the amount of uh, demo I'll be able to show. What you're going to learn now is how to very easily create an automation systems code. Take sensor readings, send it out, and how you can realize applications. Come on, it's just 4 people who have raised their hands. Everyone else? Okay. I think they are listening to the lecture via audio method or something. Let me go ahead and show you the demo. Okay. So over here, what you need to do is you just need to type here. Let us do a very simple hello world example. Okay. Along with control of a light. Okay. Turn on a light. After 2 seconds, turn it off. Uh, Repeat this activity every 5 seconds. Okay. This is something we will do. On the side, what we will do, we will write parallel codes, not the sequential codes. We'll write parallel codes. Parallelly, we want to also say hello to everyone every 2 seconds. Okay. And we will click OK. Now this will create a code for our microcontroller. Now what does our microcontroller look like? This is a microcontroller. This is ESP. This is ESP32. Now for this is connected to my laptop via USB cable. Okay, by which we can put code inside this. There is a light, a blue light as well on this on this microcontroller, which we will control. Okay, the code has been created very fast using Smowcode. This is our software. This is something we've built. So if you see every 5 seconds, on interval of 5 seconds, we are writing to a pin. Okay, so now how does a light work? Okay, you need to turn it on by giving it 5 volts or let's say 3 volts. Okay, and then you should turn it on. So what we are doing right now is we are turning it on and then turning it off, and then again we are repeating this activity. So over here our light is connected to a pin of the microcontroller. So our microcontroller has pins. If you see, there are pins over here, and these pins have a light connected to it, and that light is on the board itself. Okay, which is not glowing right now because we are yet to write the code inside. Okay. Now, one of the pins, and these pins are named as uh, 2, 3, 4, 5, 6, 7, 8. Okay, that way. So our light is connected to pin number 2. Okay. Now, how to say to a microcontroller that you have to write 3 volts. You have to put 3 volts on that pin so that the light that is connected glows. Currently, it is getting 0 volts. So we don't say 3 volts, we say 1. If you want to give 0 volts, we say 0. It is digital. Okay. So over here, we have used a GPIO write node. Okay. What is GPIO? GPIO is nothing but the pin. Okay. Pin equals GPIO equals to pin. Okay. Now, whether I say the word GPIO or whether I say the word pin, it means the same thing. Okay. For our understanding right now. Now, here we are saying that the pin number should be 2 and the pin level should be 1. And after a delay of 2 seconds, not immediately, after a delay of 2 seconds, we will turn the light off. And this entire activity will repeat for 5 seconds. Okay, every 5 seconds. And on the side, every 2 seconds, say hello everyone. Okay. Now what do we need to do? We need to click this flash button, which will now begin creating the source. This entire code that we have created right now, this codes, C language code will be automatically created, industry grade C code will be created automatically by Smowcode internally. Then a binary, ones and zeros. The microcontroller doesn't understand our language. Okay, it understands ones and zeros. This ones and zeros binary will be obtained. It is obtained now, and it is now going to try to flash it onto the microcontroller. Let me retry. The binary is already obtained. Now it is trying to flash it. Yeah, it is started to flash it. It is writing the code from the laptop, my laptop, onto the microcontroller. Okay, and within 2 or 3 minutes, we have created the code, and we can see the code also which has been created. Let us now see what the output is. So over here we can see that the light turns on and turns off. I hope everyone is able to see how the light was controlled by us automatically using Smowcode. That is the speed of Smowcode. Now you can write anything in the AI prompt of Smowcode and it will work right off. Okay, this is a very basic application that I'm showing you because we are beginning to understand. Okay, we can write take temperature, send it to the internet. Okay, for that internet has to be connected. For that we need a temperature sensor also connected to our microcontroller and so on. Now we have also, because I have my microcontroller connected to my laptop, that microcontroller is sending some information to the laptop every 2 seconds, which we have said here. Hello everyone. So we'll be able to see here in the serial monitor. So in this monitor, we are able to see hello everyone printed. So we can send data as well. So it is sending data, although same data, but it is sending some data to the laptop automatically. Now this is just simple application using Smowcode. Now we can create complex application as well. Let us create a complex application as listed here. Generate code to read temperature sensor every 2 seconds, connect to Wi-Fi and publish the temperature over MQTT. Is everyone clear about this? What it should do? Now what is MQTT? You don't know that. Okay, it is a method, it is a way by which one can send data to the internet. Okay, it is a protocol. Just like there is HTTP protocol, there is MQTT protocol. Okay, just like there's email protocol, there are multiple protocols. Okay, MQTT is a way by which it is very easy to connect an embedded system device to internet and store those values on the internet and also send it to other devices in the internet. Okay, so that is where we use MQTT. Okay, so we need to send to the internet using Wi-Fi using MQTT. Okay, what is the source of internet? Is it a SIM card module? No, it is Wi-Fi. Okay, it is not LAN cable. It is not SIM card module. It is not SIM card. Okay, mobile data nahi hai. It is Wi-Fi. So we have chosen Wi-Fi to be our internet mode. Okay, and what how we will transfer that information of temperature using MQTT protocol. Protocol is nothing but a set of rules by which a device has to communicate with the server in the internet, which is running always. Okay, so this protocol we will use, and now I'll just click OK, and this will now automatically create the code using Smowcode. It used to take 2-3 weeks to develop such codes. Now it takes just a few minutes. That is something we have developed. So the coding language is ours, the compiler is ours. Has anyone here heard about a coding language from India? Very few are there. And we are one of the very few first coding languages in India. So yeah, the code is created. This code again reads like a human. On start, Wi-Fi start, and connect to a router. Then if the Wi-Fi is connected, connect to MQTT server. Every 2 seconds, if the Wi-Fi is connected, read from a sensor, temperature sensor. This temperature sensor is called THT11. It is reading the value, the ESP32, the microcontroller is reading the value from the temperature sensor. Once it has read the value, it is publishing that information using MQTT. This is how very quickly you can create code. Now, because we don't have the temperature sensor with us, we will go again to our AI and we will now try creating every 5 seconds, every 1 second, 0.1 second, read from button on pin number 0 and send it via MQTT to /gate/temp1 topic. So there's a way by which we can send information via MQTT, and we need to say the topic as well. So we are going to use this new feature. So there's button name topic that we will use, and this button name topic will be having just 1 minute. Yes. Yeah, this button name topic is where we will be sending our information. In the server as well, where to exactly send the information, we need to tell the topic. And the server name, MQTT server, is, for example, I will tell you now, it is mqtt.smowcode.com. We will create an IoT application right now. So whatever the button value is, okay, we will send it to the internet and we will monitor it as well. So this is the code that we are writing, and we are asking Smowcode to write. It will choose Wi-Fi by default. What will happen? What will be the output of the code? When we click the button on the internet somewhere, we will be able to see. So over here, we have an internet dashboard decoration, okay, which can show us some information in some or the other way. Okay, it is there currently there on my laptop. Okay, So over here, it is creating the code. It has almost created the code. I have to specify the router name now. So my Wi-Fi router's name is Smowcode Adhik, and the password is Smowcode. Don't tell anyone. Then over here, it should connect to MQTT. Is it connected to the right MQTT? Yes, it is connected very well. Then it is every 1 second, every 0.1 second, if it is connected to the internet, it is performing a read. So I don't want a special read, I want a normal read. It is reading from a button. It should read from pin number 0. Whatever the pin number 0 has a button value. What is button? We need to understand what a button is. A button is either 0 or 1, whether it's pressed or not. Okay, that button's value, whatever 0 or 1, should come to us as a microcontroller. Okay, button is external to the microcontroller, but when we take the value of the button, that value should come to us. That value comes in a variable called pin underscore level. Okay, this is a magical entity that holds the value. Okay, this pin underscore variable, pin underscore level, we will give it to our pin underscore level. We will give it as a message to MQTT. Okay. Now let us not go into much detail. Okay, and I'll just flash this code. Flashing means putting the code onto the microcontroller. Now this will again create the professional industry grade code using MQTT and so much other features, Wi-Fi, MQTT, button, GPIO. Okay, it will now create the code. Once the code is created, it will flash, that is program the microcontroller. It will write onto the microcontroller the entire code, and that code will begin running. Okay. Now, on the side, this is where we will be able to see the output over here on the bottom right. This is where we'll be able to see on the top right here. Yeah. So in case of microcontrollers, we need to keep disconnecting and connecting the microcontroller so that the program actually is burnt onto the microcontroller well. Flashing sometimes takes time. If it has Wi-Fi application, then the code becomes big, and it takes time for in general, for the microcontroller to receive the entire program, including Wi-Fi. We are creating an IoT application, by the way. We are currently connecting that button as a sensor to the internet. How is it connecting to the internet? Using Wi-Fi. How is it getting Wi-Fi? Because the hardware, the chip that we saw, okay, that chip, it has, I cannot move the chip right now because it's getting programmed. That chip has an antenna by which it can do wireless Wi-Fi connection to the router, and it can access the internet. When it is doing that, it will also keep telling us that I'm doing this, I'm trying to connect to the internet. Okay, so we'll be able to see the outcome. So over here, it is telling us what it is doing. It is trying to start the Wi-Fi. It connected to my Wi-Fi, and now we should be able to see the outcome. So if you see here, if I click the button, you can see 0 and 1, right? Over here. I have a button here connected on the microcontroller board itself, uh, there's a built-in button which I can use to control this to monitor. So whatever I'm doing here physically, let's say there is a bag on the counter at the airport. Whether or not the bag is there, we can now check via this method, right? We can place a button below the bag, a big button, okay, physically big button, mechanically big button, and that and there's this microcontroller which is connected, okay, to the internet on the Wi-Fi of the airport, okay. It can then send this data to the right internet facility, right? I hope everyone is with me and everyone enjoyed this IoT session and learned how to code a bit and how fast one can create a code. So Dev Prakash ji has a doubt, I think. If he has, he can go ahead. I think he can even unmute. So we are done with our lecture as such. I took a shorter break to free everyone faster. So we can now actually go ahead and discuss about your questions and answers. So we have Adinath from our team who can also help you with the answers.
Hello, everyone.
Hi Rahul, thank you for your question. So we have we don't use open source Java libraries. We use C language libraries in Smowcode. Yeah. So and we sometimes create our own, or we sometimes use open source libraries internally. But we have pre-tested libraries. So any open source library also that you will take, it won't work right off. It needs some testing, it needs some changes. Those changes are made and then it comes on Smowcode. Anything that is there on Smowcode, it works right off. That is how we have built it. How do one write such low level code? Yeah, so those low level codes you can write on Smowcode itself. In Smowcode, there is a way to do that. You can check on that. Thank you, Rahul. Anyone else who would like to move ask questions? So while everyone is asking questions, I would love to know if you loved Smowcode. You can definitely get in touch with me. And I'm sharing my contact details here. We can enable you the platform at your college. We are in curriculum of Vellore Institute of Technology. We are in curriculum of another institute in Mumbai. We are getting in curriculum of one another South Indian colleges, and we keep hosting a few programs as well for teachers. We have a Smowcode lab in Vellore Institute of Technology, VIT. It's a lab where there are many computers so with booklet, a lab experiment booklet of IoT. So what happens in case of embedded systems, in case of industry grade embedded systems is we are able to the faculties are able to teach the students basics of IoT, or let's say basics of microcontrollers or basics of embedded systems, but they are not able to teach industry grade applications, not because they don't know how that works, but because it takes 6 months to write a code for industry grade embedded systems. That coding time has been reduced to such level that within half an hour or 1 hour of your 2 hour lab session, uh, the code is done, and you can actually show practical working of Modbus, of backnet, and such difficult industry grade applications using Smowcode. And that is something that we've built uh, for Vellore and so much more. Now, yeah, so I've shared my contact details, I've shared my email ID. Please do let me know if you need help from our side to set up Smowcode in your college or your lab, and we'll be helping you out. If you have any other doubts regarding automation or anything related to embedded systems, or some place you need automation, you can feel free to reach out to me, and I'll help you out. Yeah. So thank you so much, everyone. Please do share your doubts. I'm available for the next sometime.
So if you have any question, I think there is no question. So we can conclude the today's session.
Thank you so much, Pritimoy.
Yeah. So today we are coming to end of this session. I hope that you enjoyed this session on robotics and automation. The purpose of our lecture series on emerging technologies is to learn about these technologies from experts. So tomorrow there will be another such session on quantum computing. So today's session is coming to an end here. So I thank today's speaker, Mr. Adhik, explaining the complicated so well. Yeah, and such a beautiful interactive session. So thank you again, Adhik. And we will meet again tomorrow at 5 p.m. And this lecture also will be uploaded in our YouTube channel. So in future, you can see the lectures. So, okay, we conclude the session. Thank you, everyone. Good night.
Before we conclude, there is a link that I'm sharing. This is where
Yes, yes, yes.
teachers can register themselves, and we can get in touch with them. So this is a form
Okay,
link.
fine. Very good. Very good. Very
I've
good. Very
sent
good.
it
Very good.
on the chat.
Yeah, in chat. So we
One
just
teacher.
wait for 1 or 2 minutes so you can note the information. Yeah.
Yeah. Thank you so much, Pritimoy, for having me here. It
Yeah.
was great speaking with everyone.
Thank you. So in future, again, whenever we will arrange, definitely we'll talk with you. Okay. This is
Yes.
very
Thank you so much.
informative session. Yeah.
Thank
Thank you.
you. Take care. Bye.
Right. Bye.